Okay, so this is problem 13.1.37, and they're saying that Robin Martin wants to establish an account that will supplement her retirement income beginning 28 years from now, and for each interest rate, find the lump sum she must deposit today so that $600,000 will be available at the time of retirement. And they're telling us that it's 4% compounded daily. Okay. All right, so the first thing is we have to identify what formula we're working with. And since it tells us that we're compounding daily, we know that we're working with the compound interest formula, and that's this formula right here. So we have A equaling P times 1 plus R over N to the NT. Okay. And then we're going to just identify each of the pieces in the problem that they're giving us. So they're telling us that she wants to have $600,000 available 28 years from now. So $600,000 is going to be an A amount. That's going to be an amount after some time T. So we're going to plug 600,000 in for A. The principal is what we're trying to find, because they're saying what does she need to put into the account now in order to have that 600,000 28 years later. Okay, so we're going to leave that as a P, and that's what we're solving for. And then we have 1 plus our R is our interest rate, and they're telling us we have an interest rate of 4%, so that's 0.04. We're dividing that by N, and N is the number of compoundings per year, so whatever time period we're compounding in. And we're compounding daily, so there's 365 days in a year. So we would have 365 as our value for the compounding period. And then NT is 365, and the amount of time that we're looking at is 28 years. Okay, so now it's actually, you know, from here, it's a lot of times people can get this set up, but then they get confused about what to do with the actual calculator. So we need to do this first. We need to add on the inside of the parentheses. So we have 1 plus, and you need to take the 0.04 divided by 365 and then add 1, and you're gonna, and I'm just gonna write it all out so you can follow along with me and make sure that you have these values. Okay, so this is going to become that, and you have this raised to the 365 times 28 power, that's 10,220. Okay, so now what we want to do is we want to do this next. This has an exponent attached to it, so by order of operations that would be the next thing that we would do. So let's take that 1.000, and you want to plug the whole thing in so that we can be accurate. And we're going to raise it to the power of 10,220. Okay, so you should get now 600,000 equal to 3.0646648446 is what I'm getting there. Okay, and I think that's right. I feel like for some reason I made a mistake. Let me look. Nope, that looks right. And then we have our P coefficient, our P variable right there. Okay, so now we're solving for P. We're going to divide everything by this number. Okay, so that's going to give us P equaling whatever we get there, 600,000 divided by 3.0646648446, and we get 195,779, and I'm getting 97 cents, so I must be off somewhere because their answer is a little bit, their answer is 89 cents. So let's just look and see if I made a mistake anywhere. So 0.04 divided by 365 and add 1, so we get this right here, 109589. 365 times 28, and that's right. I'm not finding a mistake, so I don't know why we're a few cents off of what they have as their answer, but at least on an exam that'll work for me. And the program should accept that.